In this video, as you see, I'm going to talk about the extreme values and the saddle point. Let's get to the saddle point and the extreme values. Before I get to the examples, there are some things that you need to know, okay? First, if we want to find, for example, the maximum and the minimum values or the local extreme values and its saddle point, there are something we need to find. The first thing that we need to find, it's called the critical points. Okay, we need to find first the critical point. How can we find the critical point? The critical point, I mean, you can find it if you find the partial derivative, for example, with respect to x and with respect to y, for example, you need to equal each one with 0. After you equal it with 0, try to solve it. If it's able to solve, you will get a point. So these points will be called as the critical point. Also, there is another way. If, for example, the partial derivative with respect to x or the partial derivative with respect to y, they does not exist. The denominator, you can say. So either way, equal to zero or DNE does not exist. So this is the first thing or the first uh, thing to find or step. The second step that you need to find, it's called the discriminant. Discriminant, and it's symboled as D. The D in Arabic mean معناتها المميز. الكريتيكال بوينت انت بعد ما توجدها في قانون معين للمميز. هلا القانون انا راح اكتبه. So the second step to find the discriminant as it symboled as the D, there is a specific formula. So let me write this formula and you need to write it and also memorize it in case you got, for example, this kind of question in the midterms or a quiz. You need to know what discriminant formula is. So the formula is f with the second partial derivative with respect to x multiplies with f times the second partial derivative with respect to y, and then negative or minus f of x times with respect to y, xy, and then squared. Okay, so this is the discriminant formula. And then how can you determine if, for example, you got a value and, for example, you need to know if it's local minimum or a local maximum or it's a saddle point? How can you know? Here you can know. So if the discriminant that you will find here is greater than 0, okay, which mean you have two cases. The first case, if the discriminant is greater than 0, you need to look to the fxx. If the fxx is less than 0, okay, so which mean you have a local maximum, okay, and if the fxx is greater than 0, which means that you have a local minimum. So From here, you can determine if it's a local minimum or a local maximum. You need to find the value of d, and the value of fxx you need also to find it, and from here you can see if it's a local minimum or a local maximum. The last point I will discuss it before we get to the examples. If the discriminant is less than 0, which mean there is a saddle point. Saddle point. And it can be written as, for example, A, comma, B, then comma, F, A, comma, B. Yeah, and this is it. So let me give you a simple example to clarify everything. Okay, so the first example says, here you have an example, f of x comma y is equal to x square negative 4 times x times y, and then plus y square, then plus 6y, and then plus 2. So always you need to start with taking partial derivatives. This is the first step. So first we need to find the fx. So starting with partial derivatives with respect to x، أول خطوة بتاخد ال partial derivative بالنسبة للx، وبعدين بتاخد ال partial derivative بالنسبة للy. تاني خطوة بس خلص هالخطوة راح تشوف بعدين شو راح نعمل. So starting with partial derivative with respect to x, here is going to be 2x, and then here minus 4y. And then, of course, I will say equal to 0. So this is the partial with respect to x. So the partial with respect to y here is going to be equal 0, negative 4x plus 2y, and then plus 6 equal to 0. Okay? Okay, from here we need to do something that we can find the point. So for example, there are a lot of techniques that we can, for example, combine those two equations. But let's say here, for example, if we combine, when we want to combine something, we cannot delete something to find the other value. But also, we can here do, we can take every x and y to the other side. So the x is going to be, for example, on the left side, the y is going to be to the right side. Okay, so from here we can say that 2x is going to be equal 4y. And then I can find the value of x. It's going to be equal, if I divide the 4 with 2, it's going to be 2y. Okay, so for example, let's say I found this value here. But until now, I didn't find any critical point, or a point you can say. So I will take this value and I will insert it to the other formula here. So here I will say, I will insert every x with 2y. So it's going to be negative 4 times 2y, and then plus 2y, then plus 6, then equal to 0. Here is going to be negative 8y plus 2y plus 6 equal to 0. Here I can say that negative 6y is gonna equal to negative 6. I moved the 6 to the right side. So here I can find the value of y, negative 6 divided by the negative 6, so it's going to be plus 1. Okay, so the value of y, it's going to be plus 1. But what about the x value? So I will take here the value of y and I will substitute it with y here. So it's going to be x is equal 2 times 1. So it's going to be 2. So the only critical point in this example is 2 comma 1. So this is the critical point. Okay, so let me make some space. Let me make some space here. So the critical point that we found, it's 2 comma 1. So the first step, as we said, we need to find the critical point. Okay, what is the second step? The second step, as we said, we need to find the discriminant. Let me move this critical to this side a little. Okay, so let's find the discriminant. The discriminant said fxx multiplies with fyy and then negative fxy and then squared. So let's find the second derivative for the fx. Oh, sorry, I forgot. I removed the partial derivative with respect to x. So the partial derivative with respect to x here, it's 2x negative 4y. Okay, and the partial derivative with respect to y is negative 4x plus 2y and then plus 6. Okay, so let's find the second partial derivative with respect to x. So f double x, you can say. So here is going to be 0 and here is going to be 2. So we can write here 2 and then times. So let's delete the f double x. Let's find the f double y. F double y, it's gonna be here 0, here is going to be 2. Here is only 2y, 6 is it's going to be 0, and negative 4x also is gonna be 0. So here we can say 2 times 2. And let's delete the f double y. So you have two choices. You can find the partial derivative with respect to x, then y, or you can do the opposite. You can do the partial derivative with respect to y and then x. It doesn't matter. But be careful that both of them must be the same answer. So I will write partial, or I will solve the partial derivative with x then with y. So we need to use this formula because we said with x first. So this equation, I'm going to take its derivative with respect to y. So taking its derivative with respect to y, it's going to be 2x is it's gonna be 0, and negative 4y, its partial derivative with y is gonna be only negative 4. So here is going to be negative, negative, and then negative 4, and then squared. Okay, and I don't need those anymore. Okay, so let's find the discriminant here. Here is going to be 2 times 2, 4, 4, and then negative. Negative 4 squared is 16. So 4 negative minus 16 is going to be minus 12. So this is the discriminant. So we need to find right now the local minimum, maximum, and its saddle point. So we said if there is a local minimum or maximum, the discriminant must be greater than 0. So negative 12, it's not greater than 0, it's less than 0. So because negative 12 is less than 0, which means the critical point 2 comma 1, it's a saddle point. So there is no local minimum or a local maximum. Okay, so you need to write 2 comma 1 is a saddle point. Last thing that you need to do, you need to find the value of its saddle point. So you need to put in this original equation every x with 2 and every y with 1. Okay, so we can write here x square is going to be 2 square. It's going to be 4 and then negative 4 times 2, 8 times 1, 8. So it's going to be negative 8 and then plus y square is going to be 1 and then plus 6 times y, which means 6 times 1, which is 6, and then plus 2. So let's combine them. 6 plus 2, 8, plus 1, 9. 9 minus 8 is 1, and then plus 4 is 5. So at this point, there is a saddle point. So you can call it here before, here, you can write f of 2 comma 1. And after you write the final solution for the saddle point, you could write, for example, there is a saddle point at the point. You can say 2 comma 1 and then comma, you open a parenthesis and you write 2 comma 1. And this is it. And yeah, so this is the first example. Okay, let's start with the second example. As you see here, the example says f of x comma y is equal to 4 times x times y minus 4x to the fourth, then minus y to the fourth. So we need to do the same steps as we did in the previous example. So first step, we need to find the partial derivative with respect to x and partial derivative with respect to y. So starting with x, here it's going to be 4y. The partial with x here is 1, so what's left here is 4y. And then minus 4x to the third. Here, it's a power rule. And then y to the fourth is going to be 0. So this partial is the first with respect to x. So taking the partial derivative with respect to y, it's going to be here 4x, then minus 4y to the third. Okay, and don't forget equal to 0. So this is the first step to start solving this equation. So the second step, as I said, we need to do something with those equations. Let's say, for example, if I want to combine them, I will not be able to delete or remove something to find the other value. It's difficult. So I need to deal with the first or the second one. So for me, let's start with this equation here. So I can say that 4y, it's going to equal to 4x to the third, right? I didn't really do anything. I just moved this negative 4x to the third to the right side. That's it. So I will get 4y is equal 4x to the third. So let's divide 4 in both sides. So the 4 will cancel. So the 4 here and here will cancel. So the solution solved itself. So which will give us y is going to equal x to the third. So this is the first hint that I took. So from here, I can insert this equation in the second equation. So let's use it. So here we can say that 4x minus 4, and then x cube, and then to the third. X cube from the original equation here, and then there is a cube to all, or with the y. So there is 2 cube here, you can say. Then equal to 0. So the 4 here can also cancel if you moved one to each other and you moved it back again. So the 4 will cancel here. So the 4 will cancel. So what's left here is x negative x to the ninth equal to 0. So here I can solve this equation easily. Okay. So we can take x out and then we can say 1 minus x to the 8th. So what I'm doing here, but اللي أنا عملته هلأ أخدت البارشل ديريفيتيف بالنسبة للإكس والواي، بعدين أنت أو بشكل عام بتشوف إنه هل أنت فيك إنك تختصر شي بالمعادلتين إنه أنت تجمعهم. مرات في بعض المعادلات لما أنت بتحلن ممكن إنك تختصر شي إنك تطلع القيمة، فبتصير عندك الحل بيصير سهل. هون مثلا أنا ما قدرت، اضطريت مثلا إني حل وحدة مشان إني استخدم هالمعادلة حتى إني أطلع قيمة وحدة بالمعادلة الثانية. فهون أنا مثلا طلع عندي y equal x تكعيب، وديتها بالمعادلة الثانية ضل عندي x ناقص x أس 9. بعدين أنا من هون بقدر آخذ عامل مشترك، أخذت الx برا وضل عندي هي. So from here let's continue. Uh, After we took the x out, we found that there is 1 minus x to the eighth in parentheses, and then of course we will say equal to 0. So from here I can also make this more simple, or I can divide it, you can say. So this 1 minus x to the eighth, I can write it as 1 plus x to the fourth, and then times 1 minus x to the fourth, and then equal to 0. Okay? So also from here I can make it more simple. How? I can write only one of those parentheses. I can write it as 1 minus x, and then 1 plus x, and then 1 minus x to the fourth. Okay? And yeah, from here, let me make some space a little bit. We can delete those. No, we can delete those. And okay. From here, we can say that here, of course, x equal to 0. We can here also, or we can see that here x is going to equal to 0. So the first critical point, we can see that x is equal to 0. So this is the first critical point. The second critical point, if you solved 1 minus x is equal to 0, you can say that x is going to equal to 1. And also, there is another critical point here. You can say that x is going to equal to negative 1 if you solve this equation. And if you solve, for example, this equation, the answer is going to be plus or minus, for example, 1. So plus or minus here we found it. So we don't need to write any critical point. So those are the critical point of this equation. So what you need to do, so here we found the x criticals, but what about the y? The y, every y you need to find it, you need to substitute the x here. So to find the first critical point, here we write the zeros for the x. What about the y? We insert this 0 here, so 0 to the third is going to be 0. So this is the first critical point. The second critical point here is going to be 1 to the third is going to be 1. So x is 1, and y, after I put it here, is going to also be 1. The third value is negative 1. I write the x here. What about the y? Negative 1 to the third is going to be negative 1. So these are the critical points of this equation. So let's make some space. Let's delete those. And let's delete those. Okay. So the second step, as I said, we need to find what? We need to find the discriminant. So to find the discriminant, there is an equation. It's called, or it's written as fx or double x multiply with f double y, and then negative f x with respect to y then, and then square. So we need to find the f double x. So let's find the f double x here. The f double x is gonna be 0, and negative 4 times 3 is gonna be negative 12x square. So this is the first value, negative x, or negative 12, I mean, x squared. Okay, so let's find the y. Let's find f double y. F double y is going to be equal here 0, and then negative 3 times 4 is 12, then y to 3 negative 1 is 2. So then times negative 12 y square, and then minus. We need to find the f with respect to x, taking it with respect to y. So let's take this equation with respect to y. So taking this equation with respect to y, it's gonna give us 4, because I'm dealing with respect to y, so this x cube is gonna be 0 and the 4y is gonna be 4. So negative, and then 4, negative 4 squared. Okay, and let's delete those values here. Okay, or the lines, I mean. Okay, so from here we can say that negative 12 times negative 12, it's gonna be plus 144, and then x square times y square, and then negative 4 square, it's gonna be negative 16. From here I can take 16 out. So if I take 16 out, it's gonna be 144 divided by 16. So it's gonna be here 9, then x square y square, and then negative 1. So this is the final answer for the discriminant. So let's start with the first critical point, 0, 0, 0, comma 0. So when the d or the discriminant is 0 and 0, okay, what's the answer is going to be? So we need to insert every x and y for discriminant, for this critical point, I mean, in the discriminant equation here. Okay, so we can write that 16 is going to be equal 9 times 0 times 0, negative 1, and then it's going to be equal 0 times 0 times 9. Those will cancel. So what's left here, 16 times negative 1, which it's negative 16. So the discriminant here is less than 0. Because the discriminant is less than 0, which means that there is a point saddle point at 0, 0, and then f of 0 of 0. So we need to find the value of f of 0 and 0. So when the discriminant is less than 0, you need to substitute those critical points in the original equation. So we can say that f of 0 comma 0, it's gonna be 4 times x times y. So 4 times 0 times 0 is 0, negative 0, negative 0. So it's gonna be also a 0. So this is the first critical point. So let's write or find the second discriminant. So let's delete this space. Okay, so dealing with the second critical, when the d is 1 point or 1 comma 1. So we can write as 16, then 9 times 1 squared times 1 squared negative 1. And it's going to be equal 16 times. Inside the parentheses, there is going to be here 9 times 1 times 1, negative 1. It's going to be 8. So 16 times 8, it's going to be positive 128. 128. So 128 is bigger than 0, right? So from here, we need to determine if it's a local minimum or a local maximum. What we need to do, we need to look to the f of x. So we need to find the fxx. So the f double x is negative 12x squared, right? And the critical point for the x what is 1? Yeah, here, sorry, is 1. So let's substitute 1 with here. So the final answer is going to be for the f double x is negative 12. So the because or we can say and f double x f double x is equal negative 12. So because the f double x is negative value, which means that we have a local maximum. Okay, so the last step that we need to do for the discriminant here, we need to find the value for the original equation for the f1 comma 1. So 4 times 1, it's going to be 4, and then 1, the x is 1, so 1 to the fourth is going to be negative 1, and then negative, the y here also is 1, so 1 to the fourth is also 1. So the final answer is 2 as the local maximum. So this is the second critical. Okay, so the last critical point, is the d of negative 1 and negative 1. So 16 times 9, then times negative 1 squared times negative 1 squared and then negative 1 equals 16 times negative 1 squared is 1, negative 1 squared is 1, so 9 times 1 times 1 minus 1 is going to be 8, so 16 times 8 is going to be 128 again. So 128 is bigger than 0, so we need to find what? We need to find uh the critical sorry, we need to find the f double x. So the f double x is negative 12x squared. And the value of the f double x, or the value of x here, is negative 1. So let's insert double 1 or minus 1 in the x. It's going to be negative 12 times negative 1 squared. So the final answer for the f double x is going to be negative 12. So it's the same, the value as here. So we can say that here there is also a maximum, local maximum. And if you find the f negative 1 and negative 1, you can see that the answer is also gonna be positive 2. Yeah, and this is the final answer for this solution. This is the final example for this video, and it's really easy. You can pause the video and try it if you want. And yeah, so let's start. So the first thing that we need to do, we need to take the partial derivatives, right? So taking the partial derivatives with respect to x, here is going to be 1 over 3 and then times 3x squared, and then negative 2x, and then here plus y. Then the 3's can be cancelled. So what's left here is x squared negative 2x and then plus y. So this is the first equation. Okay, so the second equation, or the second partial with y, 0 0, and then we will get x, then plus 1 over 2 times 2y, then negative 2. So the final answer here, the 2's can be cancelled, and the second equation is going to be x plus y and then negative 2 is going to be, we can also of course write here is equal to 0, and here also we can say equal to 0. So in the previous two examples, we couldn't find, how can I say, like we couldn't combine the two equation and find the one, or for example to find the x to find the y. No, we solved in the previous two examples, we solved equation by equation. So we finished the first and we moved to the second. Okay, so here is different. Notice here that we can write it here. For example, we can write x squared negative x plus y is equal to 0, and here x plus y negative 2 is going to equal to 0. So notice here that if we multiply here with the minus, we can cancel the y here. So what's left is only the x variable, right? So yeah, every question has a technique to use. So every step after you find its partial derivatives, always look for the combined terms. If you could delete or combine values, it's the better way. So here, if we multiply with minus, here, okay, so here is gonna be negative, and the positive y is gonna be negative, and the negative 2 is gonna be positive 2. So the y's can cancel here. So let's combine this equation here. So if you combine those two equations, you will get x squared, and then negative 2x negative x is going to be negative 3x, and then plus 2, then equal to 0. Now, can we solve this equation easily? Yes, we can. How? We need to take two numbers that the sum of them is negative 3, and they multiplies with positive 2. So we can take the 2 and the 1, or negative 2 and negative 1. So x minus 2 and x negative 1. So negative 2, negative 1 is negative 3, and negative 1 times negative 1 is going to be positive 3. And then going to be equal to 0. So from here, we can say that x is going to be equal to 2 after you move the 2 to the right side. The final solution for the x's is going to be 2, and x is going to be 1. Okay, so here we found the x values. What about the y values? So to find the y values, you have two ways. You can choose one of two equations right here, and you can substitute with the x, and you can find its y values. So for example, let's find, for example, first the 2. If we start, let's say I want to use this equation and I want to start with the x equal 2. So it's going to be 2 plus y negative 2 is going to be equal to 0. So the 2 minus 2 is going to be 0. So y is going to be 0. Is that correct? I don't know. If you want to know, you can check or use the second equation. If the answer is 0, which means your answer is correct. So 2 square, here I'm gonna use this equation. So it's gonna be 2 square is gonna be 4, and then minus 2 times 2 is 4, and then plus y, then equal to 0. So those cancels. So y is equal to 0, which means my answer is correct. So let's deal with the second x. So I will insert, for example, the y here, the x here. So 1 plus y and negative 2 is going to equal to 0. So 1 negative 2 is going to be y minus 1 is going to be equal to 0. So y is equal to 1. So here we have two critical points. here we have two critical points, which is 2 comma 0 and 1 comma 1. Okay, so let's continue. let's make let's make some space here a little. Okay, so the second step, as I said, we need to find the discriminant, right? Okay, let's finish. Let's find the fxx and fyy and fxy before we write the discriminant, so we can solve everything easily. So the f here from this equation, the f double x is gonna be 2x negative 2. And from this equation, because it's related with y's, so we can say that here f double y is gonna be equal to 1. So let's find the f with respect to x with respect to y. So here, taking the x with respect to y, here there is only one y and it's going to be equal to 1. So if you take this equation with respect to y, so every x is here is going to be 0. What's left for the y here? So the answer is 1. So writing the discriminant equation is going to be fxx times fyy and then negative fx y squared. So here is going to be equal to 2x negative 2 and then times 1 and then times 1. Okay, so yeah, so from here we can say that 2x negative 2 and then negative 1. Sorry, here there is a minus. Here minus 1 squared. So 2x minus 2 times 1. So the discriminant equation is going to be 2x negative 3. So this is the discriminant. What's left here? Just a piece of cake. So we need to find the discriminant for the first critical point, for example, 2 comma 0. So let's write 2 comma 0, 2 comma 0, and it's going to be um, 2 and then multiplies with the 2 here, the x, 2 times 2 and then negative 2 negative 1. Or I can use in a fast way this equation, 2 times 2 minus 3. So it's going to be 2 times 2, 4, negative 3 is going to be 1. So 1 is greater than 0, right? So what we need to determine is the f double x. So the f double x here, notice it's 2x minus 2, not minus 3. Be careful. So 2x minus 3 for the f double x. And the x values here in this critical is 2. So we can say that 2 times 2 is 4, minus 2 is 2. So the 2 here is greater than 0, which means that you have a local minimum. We said that if the f double x is less than 0, you have a maximum value or maximum or local maximum. And if you have f double x greater than 0, so you have a local minimum. So here you can write local min, min, to the local minimum. And you can, last step, you can find from the original equation the value of the critical point, so you can know what the local minimum number is. So if you substitute the 2 and the 0 in this equation, you can find that the answer is going to be negative 4 over 3. Come on. negative 4 divided by 3. So this is the value of the critical point in the original equation. So let's take the second critical point. Okay, so taking the second critical point. Okay, so the second point is the D 1 comma 1. So let's write the equation here. Let's substitute with x with 1. So it's going to be 2 times 1 negative 3. So it's going to be 2 times 1 is 2, negative 3, so it's going to be negative 1. So as we said, if the discriminant is less than 0, which means you have a saddle point. Saddle point. Saddle point at 1 comma 1 and then comma, you open a parenthesis and you write 1 comma 1. Yeah, and this is it. The last step that you need to do is you need to find what's the saddle point number or value, you can say, at 1 comma 1. And if you substitute the 1 for x and y in the original equation, you can say that the answer must be negative 13 divided by 6. And yeah, and this is the final answer for this equation. Thank you for watching. I hope this video was helpful. Like and subscribe if you want to see more videos. And yeah, I'm in this chapter, I'm going in order. Uh, Next video, it will be about the absolute extreme values, and then yeah, it's gonna be about the Lagrange multiplier, and the chapter will be finished. Thank you again for watching, and I'll see you in the next video. بتمنى من الكل كان الفيديو واضح والأمثلة بسيطة وجدا سهلة. الأفكار ما كانت صعبة كتير. إذا بتحب مثلا إنك تشوف أسئلة كتير، ممكن تشوف الكتاب مثلا، كتاب المالتي فاريبل، فيه يعني بحيث إنه أنت تتدرب كتير في كتير مسائل بكمية هائلة. بس لكن هدول المسائل بيفرجوك الصورة بأبسط صورة، أو بتتعلم الأمثلة أو كيف تحل بأبسط صورة. وشكرا على المشاهدة and I'll see you in the next video. Thank you.